8400 lights. And today I thought I would show you this fun little project I decided to do. When I was shopping in my local big box store at the end of last season, I came across these oversized Christmas ornaments that they were selling. And these were advertised as an LED light that you can turn on for a set amount of time, and they're on a timer, and then they shut off. And I thought that's great, but if I wanted to incorporate these into my light show this year, I would have to rewire them. And so I thought I would do that. Now here's a little tip. When I first thought of this project, I was just going to rewire them using a standard bright white type light because they do have these different colored shells and everything and different shapes. But as I thought about it some more, and after I had purchased them, I thought, wouldn't it be cool to rework them with RGB lights instead of just a regular white light, and then they could be any color. So if you're going to do this with an RGB, I encourage everybody to get the clear white, or the white lens here, rather than the colored lenses. I'll have to switch this kind of out maybe the end of next year to get some with all white rather than these colors in them. But this will still work for now. So we're going to go through and actually deconstruct this and then rebuild it with an RGB chip inside rather than the white chip, and also some extra wiring for connection into my computerized light show. The first step in the process is to disassemble the existing unit, and then we can start rewiring it. So luckily this lens just kind of screws off from this base here. Set the lens aside, and we can see here that this is their light source, their LED light source that's on this little pedestal here. I don't know if you can see this in here. There is a little switch here that controls the functions of the unit. There's 3 small screws on the outside edges. There's another one here, we'll take that apart. And then on the back side here is this little button. So we'll go ahead and start taking some of these screws out and see what we find. We took out this one screw here in the middle, and that allows this plate to come up and out. And we can see here that we've got 3 AA batteries in here, which is what it uses as a power source. So we'll go ahead and pop those out, as we won't be needing them. And we're going to rewire this for our RGB lighting. So other side. And that's about all we can see in here, so we'll go ahead and put this plate back in and put that screw back in as well. Now we'll go ahead and take these other 3 little screws out of here, and hopefully that gets me into the rest of the unit. I've taken out these 3 screws, and now this part of the unit just pulls apart. And we can see now that we have a couple of wires running from the back of a switch down here at the bottom of this. And then those wires run up to a little control board here that then ties into our battery compartment, and then must tie into this front thing here. So we know we don't need any of this, so I'm going to go ahead and cut these wires. And then as I look down in here, I see that that little switch is actually held in the bottom there by a couple of little screws. So I'm going to take those screws out. I'm going to take these out and discard them. And then lo and behold, this little button right here pops right out. And this gives me a nice starting point for a hole in the unit to run my new wiring. Now I'm going to want to add a strain relief connector on this, because if I just put my wire in there, it can get yanked easily, and also really provides no water prevention from getting into my fixture. Now we'll go ahead and disassemble this bottom half of the unit. Again, we'll start by clipping these lead wires from the battery compartment into this little electronic board here, like so, and so. And then if I look, I can see a couple of screws down here, and we'll take those out and see what that does for us. And that actually gets this board free, and you can see on the other side of the board here's that little switch we had. And then we have a couple of lead wires that are going off to the LED chip on this other side here. And again, we won't need those, so we'll cut those out. And then again, we see a couple more screws down there, which must be holding this post in place. So we'll go ahead and take those out. And lo and behold, our little post with our LED chip comes out. And we'll actually take and save these screws. As we look at this unit now, we can see here that we have a couple of really nice holes in the unit and a couple of screw holes that might be really effective for running our new wiring. Here is an RGB chip that I've prepped up for this little project. I've been getting these chips off the internet, usually in about packs of 10 or so for less than $10. So they're pretty inexpensive. And in this case, I've gone ahead and I've soldered a common lead on it here, this black wire. And then I've soldered my three colors on here, my red, green, and blue. And then on the ends here, I've added these little ferrules which help protect my wires and will be very useful when I go to connect everything together. So again, these chips have these little holes in them at the top. See there? That looks really promising that I can take one of my little screws that was holding the post in and I'll put that through this hole. And again, on this base unit, I've got these two screw holes down here that were holding in the prior post, and then I have this long rectangular hole that they had put in there for the switch. So it looks pretty easy that maybe I can screw my RGB chip in using these existing screw holes and then use this long rectangular hole to route the wires down and through. So we'll do that. And I just want to be a little bit careful when I'm doing this, as these are kind of delicate solder connections. But lo and behold, that works really well. And I'll just continue to kind of tuck these wires down in here. And there, I now have a new RGB chip mounted inside of this base unit. And then on the back side, I have my wires coming through with my little ferrules on here. And this is a strain relief connector that I got, again, off the internet. Nice little unit, has a little part that comes out, then this grips my wire, and then theoretically this would go through to the other side of my project and I'd have this nut to lock everything on. So I'm going to go ahead though and have to expand this hole a little bit to make it large enough for this strain relief, because this is a bigger hole than what I have right there. Now we have this hole expanded here that's big enough for our strain relief connector. The one unfortunate thing, however, is if you remember we had that little switch down here, and that switch was actually mounted inside of a square box. That once I put this new strain relief in, that little square mounting down there for the old switch that was there actually interferes with putting this nut in place. So rather than putting the nut on there, I'm just going to go ahead and super glue the bottom of this strain relief connector to the top of my housing here. Again, try to get a good coating of super glue all the way around that, not only so that it bonds, but we try to get some water protection. And I'll just go ahead and shove that right in there. And we'll give that a couple minutes to set. While that super glue sets up, we'll go ahead and start wiring everything together. Now, one of the things with RGB lights is that you typically have to reduce the voltage on the red LEDs as opposed to the green and the blue LEDs. The green and blue can run pretty close to 12 volts, while typically the red can only run about 9 volts, and if you run it at more than that, it tends to burn it out. Again, that's kind of dependent upon the LED chips that you use for this, but that's fairly standard. So the way that we want to reduce the voltage is by running it through a resistor. So I have these packs of resistors here, and I'll pull one out. So in the past what I've done is started soldering these resistors in line. But what I've started to do is I found that these RGB chips do tend to fail. And if they do fail, it's quite a bit of work to cut them out and then resolder them back into place. So that's why I started adding these ferrules here. And I found these little, what I call terminal blocks, again online, that I thought if I connect everything through these terminal blocks instead, then if I have an RGB chip that fails, I can quickly disconnect it, replace it, get the fixture back up and running again, and then replace the RGB chip inside and not have to deal with unsoldering it and resoldering it as part of the fixture itself. So I'm going to go ahead and this is a strip, and I'm going to cut out 5 of these, 1, 2, 3, 4, 5, to make this terminal strip a little bit shorter. So now I have a strip of 5, and you're saying, well, why are 5? Again, the 5 is so that I can accommodate this resistor as well. Rather than soldering this to my red line, I can actually just run it through my terminal strip now, such that if something were to happen to the resistor, again, I can easily replace the resistor as a separate component. Well, now I have this resistor going into 2 of the lugs of my terminal strip, so I can run my red power through the resistor and back out again to get that drop in current or drop in voltage for my red RGB light, which is why I have 5 lugs on my terminal strip rather than 4. So now I'll go ahead and plug in the rest of these wires that are going to my RGB chip itself. And other than the red, the order doesn't really matter. Here is my terminal strip attached to the wires that then are going to my RGB chip. And again, I have my resistor here to drop the voltage onto the red. So next thing I will do is I will actually go ahead and add my pigtail wire to the top half of this housing. And this is a standard pigtail wire that I put together already. I tend to use these little JST 4-wire connectors for my RGB lighting. Other folks use other connectors, so I've just soldered that onto some alarm cable, which is again what I use for my runs for my RGB. And then again, I have put these little ferrules on the bottom side of this pigtail for connection into my terminal block. So I'll go ahead and install this now. I'm just going to run these through. Again, from the standpoint of if I ever decide to change pigtails, it's a nice modular solution where now all I have to do is come in and unscrew the pigtails from the terminal block here and put in a new pigtail, or if I change pigtail connectors, anything like that. And now all I have to do is screw these connections onto the other side of my terminal block. So here are the first 3 connections, blue to blue, green to green, black to black, and then we just take this red wire over and come in on the opposite side to run through our resistor. And then we have all of our connections made through this little terminal block. So again, if anything happens to my RGB chip, I can quickly disconnect and replace it. Or again, if I want to change pigtails or pigtail connectors at some point in time, I can come in and easily and quickly disconnect it and put in my new pigtail without having to cut and resolder a number of connections. Or again, if my resistor gives out, I can quickly come in and change that resistor out. And now we'll go ahead and reassemble this top housing. So we'll just shove everything in. The nice thing about this being a nice big housing is there's lots of room in there for that terminal block. And there, in just a few minutes, I've actually changed out and rewired this entire fixture from a battery operated white only or colored only, depending upon what you get, light, to now having a programmable, adjustable RGB chip in there. So we'll go ahead and screw the lens back on. And I can test this out. I have my little portable RGB tester. So we'll connect that up. And there's red, there's green, and there is blue. So I hope you saw how easy that was to actually rewire and rework this fixture from a little battery operated unit into an RGB unit that is capable of being used in a computerized light show. Thanks for watching, and please check out our other videos on our YouTube channel, 8400 Lights.